Here we're looking at an isosceles triangle, an isosceles right triangle, which means that this angle here is 90 degrees, and these two angles are the same. With an isosceles right triangle, there are two equal sides, and the angles opposite those are equal angles. That means that these angles must be 45 degrees each, and the length of these sides must be the same. Now, it doesn't matter here if we put their sides to be 1 or any other value as long as both values are the same. Now, looking at the Pythagorean theorem, a squared plus b squared equals c squared, we know that if the sides are both 1, we get 1 squared plus 1 squared, which is just 1. So our c squared, our value for our hypotenuse, is 2, and if we take the square root of both sides, then that value is the square root of 2. So here we have the square root of 2. Now let's take a look at our trig values for this. So we're going to look at the sine of 45 degrees. Now it doesn't matter which one we're looking at, whether we're taking this angle or this angle, because they're both the same. So looking at this one, this is our opposite side. This is the adjacent side. And of course, this is the hypotenuse. So the sine of 45 degrees is opposite over hypotenuse. Now, again, we typically don't want a radical in the denominator, so we could multiply both the numerator and denominator by the square root of 2. This gives us the square root of 2 over 2, and that's the same value. And the cosine of 45 degrees is also the adjacent over the hypotenuse, which is 1 over root 2, which we can say is also equal to root 2 over 2. And the tan of 45 degrees, which is opposite over adjacent, is 1 over 1, or just 1.